Okay, let's continue our exercise. And last time we talked about this battery life, right? Let me give you some example case, which I talked about last time. For example, let's say there are 2 million iPhones sold in particular market, and we want to understand what is the battery life, how long the battery functions. But we cannot look at this 2 million iPhone, 2 million units of iPhone, obviously. We don't have enough time, we don't have enough money. So we decide to take a sample. Let's say we have just a sample with 100 iPhones out of this 2 million. Obviously, you should remember that when we do this sampling, we should not be biased. We should not be prejudiced. In other words, we got to have some fair method to choose this sample. The best way is to make sure that we do that in a random manner. So we already learned that random sampling. You remember we already did that maybe last week or 2 weeks ago probably. So when you have all this data, you generate a random number, right? You generate a random number, and once you generate a random number, obviously you use rand function, right? Rand function in Excel. So you generate a random number, and you sort this random number, and from the smallest to the largest. Usually the random number is between 0 and 1, right? Obviously. So you sort this random number, and then you choose the first n elements. N is a sample size. That's the random sampling. And I don't want to go over this random sampling, but I hope that everybody understands why it's necessary to use that kind of unbiased method to determine the sample. Otherwise, if the sample is skewed or biased, then any outcome from this analysis will be unreliable, right? Okay, let's assume that we did some random sampling, so that now we have n equals 100, that's our sample. And then we measure this x bar and s, okay? So in this case, we suppose that we have x bar equals 991.02 and s is 87.17. So the question is, let's say someone asked me about the battery life, true battery life. So someone asked me about what is the true battery life? True battery life. And especially, let's say if someone asks me about a very specific question. For example, what is the 95% confidence interval of or for the battery life? Okay. If someone asks me about that, then I can go back to this equation. You remember we had the equation something like this. P x bar minus z alpha over 2 s over root n mu x bar plus z alpha over 2 s over root n is 1 minus alpha. And in this case, we fortunate to have the sample size is big enough. Not that big, but I would say n is 100. N equals 100 is not that bad. So the first approach we want to use is using this one. And assuming that n is relatively large, I hope that we can use these g values rather than t values. Okay, if this is the case, how you can calculate these numbers? So why don't I go ahead with you? Because we already know these values. For example, we already know x bar is 991.02 minus g alpha over 2. We want to have 95%, so it should be 1.96, assuming that we can use normal distribution or at least approximation of a normal distribution. So if this is 1.96, and then S is already we have here, that's 87.17, 87.17 over root 1 square root 100, which is obviously 10, but I want to use the full values. And then we have 991.02 plus 1.96 times 87.17 over root. Okay, that's what it is. That's what it is, right? So I hope that you can get all these numbers. Then eventually what we will have is going to be 973.93 mu less than or equal to 1008.11, which is 0.95. That's our answer. So when someone asks me about what is the true battery life of iPhone 5 or iPhone 6 or whatever, or even yet that person asks me about what is the 95% confidence interval of that battery life, then my answer to the question is the true battery life is between 973.93 and 1008.11. So when I say something like this, how much am I confident? I'm confident at 95%. In other words, I'm pretty much confident when I say this to you. Okay? So this is a very strong, statement actually. Now, for some reason, let's say we think that n is not big enough. Then how can we answer this question? And we already know how we should answer this question. So the second approach, assume that, suppose we believe that n is not large enough. Then we change the equation a little bit so that it becomes x bar minus t alpha over 2 s over root n and mu and less than or equal to x bar plus and t alpha over 2 s over root n, and then it's going to be 1 minus alpha. Okay, so everything is the same except for this. Then what value should I estimate? If I still use 95%, okay, then this should be t.025 with n is 100. So why don't you try to get these t multiples? Okay, we already did this, so you probably find it easy to calculate this one. Okay, so why don't you try to calculate this t multiple using t dot inverse function? Okay, very good. I hope that everybody was able to calculate this. How should I do this? I can do this like this. Let's say t dot inverse 0.025, and what is the degree of freedom? It's not n, right? I already said it should be n minus 1. Therefore, you need to put 99, right? So if you do that, you will probably have minus 1.98422. So it's very similar, right? We used 1.96, but now we have 1.98, which is very, almost the same, But because we decide to use this t-distribution, we want to use this 1.98422 instead of 1.96. And if you do that, what happens is that, okay, the true value is ability is going to be 973.72, and mu, that's 1008.32 is going to be 0.95, in other words 95%. So this is not much different. There is not much different, right? There is a slight difference. Probably the range is a little bit larger, a little bit bigger compared with this one, okay? But overall, I think that this is pretty much the same, because we have very similar multiples. Now, the interpretation of this outcome is exactly the same as that we used when you use g-values. The interpretation is, what is the true value of battery life? What is the true value of battery life? The true value is between 973.72 and 1008.32. And when I say that, how much confident am I? I'm confident at 95%. In other words, I'm very much confident about these outcomes. So this is a very nice example, and we can use this example as some benchmark we can use when someone asks me about this estimate about the true value about population and so on and so forth. Okay, very good. Now I want to move to another exercise problem, and in this case we actually calculate all these numbers ourselves, but we already know that in our Excel, especially StatTools, we have a very nice tool that helps us to do this confidence interval estimate. So why don't we talk about this problem? Number 4 in chapter 8. So we can see how we can use this Excel StatTools to calculate all these confidence interval. And I ask my TA to show you how to do this. Okay, he will explain how to use the StatTools and to calculate the confidence interval. So I want to give you, let's say, 4 minutes or 5 minutes to read the questions in this problem, number 4 in chapter 8. And then after that, I will ask my TA to show you how to use the StatTools and how you get this confidence interval. Obviously, before you get this calculated confidence interval, you should do this sampling first. And remember that we learned 2 different ways. One is you can actually generate a random number, and then you get your own, you determine your own sample, or you use the StatTools, and in the StatTools you actually ask the StatTools to calculate or to select a sample, random sample. So I think that your TA will demonstrate how to get this random sample, and then how to use the random sample and using StatTools to get this confidence interval. And then I will make how to interpret that outcome. Okay, So why don't you take 5 minutes to read these questions and try to understand how you should approach this problem.